Hey guys, welcome to the Math Base. What goes up and down? Makes you feel like you're going in circles and has siblings. Sine, cosine, tangent graphs. Basically, circular functions. But this will not be you by the end of this video. Armed with the knowledge of unit circles and quadrantal angles, we're going to figure out how to draw them today. And if you haven't armed yourself yet, then what are you doing with your life? Go watch those videos first and then come back to this one. Links in the description. Okay, let's get started. Now, remember, to draw any graph, you need an equation or a function. That equation will tell you the relationship for finding points on said graph. Each point has an x value and a y value. Let's look at sine first. This is what the sine equation or sine function looks like. Y equals sine of x. This means every y value is a sine value, and we can get them using angles of x. We can get these from our unit circle. You will need 5 quadrantal angles: 0, 90, 180, 270, and 360. So go ahead and obtain the sine of these angles from your unit circle. Remember to pick out only the y values from the 5 points on your unit circle, because every y value here is a sine value. But do not confuse this with your sine graph. They just happen to be the same thing. Now that we have all 5 angles and corresponding sine values, we can formulate new coordinates based on our sine equation. Remember how x is an angle and y is a sine value? Pair up the values you just found like this. Now all we need to do is set up your graph, plot these points, and connect the dots. When you set up your graph, remember to label the axes correctly as sine of x versus x, and place little ticks on each axis like so. Plot your points and draw through. Now, when you draw through the x-intercepts, make sure you're coming in at an angle. So not like this. We're not trying to draw half circles, alright? And we're done. I hope that made sense so far. If you have any questions, please comment down below and I'll try to help you out. So, let's look at how we draw the cos function now. Its equation is y equals cos of x. If you haven't guessed it by now, the approach is very similar with one difference. On your unit circle, you need to pick out the x values from the same 5 points. Once you have them, pair them up with their angles to create your coordinates. Then, set up your graph for cos of x versus x with the same ticks. Plot your points and draw the curve, making sure it passes through the x-intercepts at an angle. So not like this. Please. Okay? Okay, moving on. The tangent function is tricky to draw. Makes less sense than it looks. Its equation is y equals tan of x. This sounds a little crazy to say, but we need 9 points. Yeah. And some of these points aren't even points. But most of them are not difficult to get. 5 of them are quadrantal. Since tangent values can be found by dividing sine over cos values, you can get the quadrantal ones from what you found before. So, for each angle, these would be your tangent values. 3 of these can be paired as coordinates, but the other 2 are undefined because they divided by 0. So they become vertical asymptotes at x equals 90 degrees and x equals 270 degrees. That is why they are not really points. As for the last 4 points, they are somewhat easier to find. It's based on the angle of 45 degrees. The tangent of 45 is 1. Its other half is 135 degrees. So tangent of 135 is -1. The last 2 points simply use the same information at 225 and 315 because they are symmetrical. If you're confused about symmetry properties, check out my video on this. Link will be in the description. So these are the coordinates. Now that we have them all, we can set up our graph of tan x versus x. This one has more ticks. Draw the asymptotes and label them. Then plot the points. And guys, we are almost there. As you're drawing through the points, you want to come close to the asymptotes, but not touch them. Something like this. Also, the curve comes in at an angle through the x-intercepts. Nothing new. And that's it. We made it! So, in summary, these curves can be drawn mostly from the quadrantal angles found on your unit circle. You might notice each curve has a kind of symmetry to them as well, with every quarter drawn. That has something to do with symmetry properties, which is addressed in a different video. But I hope this video has helped. If it has, please like the video so that others can be helped by it. If you have any questions or suggestions for new videos, please let me know in the comments below. And don't forget to subscribe and ring that bell so you know when the next video comes in. Thanks guys, see you in the next one.